Hi, my name's Daniel. I'm a security architect for Vectra based out of the United Kingdom. And in the next couple of minutes, I'd like to walk you through the Vectra modern NDR for cloud infrastructure. So let me just start by outlining the problem here. And this encapsulates it nicely. And this is the reason why customers invest in the Vectra platform. And that is the modern network. And the modern network is one in which consists of various what we call domains. So that consists of on-premise infrastructure hosted in physical data centers, along with physical campus networks, and very often OT environments as well. In conjunction with that, you've got remote workers accessing SaaS applications via SASE infrastructure. And then you've got in some cases, very, very aggressive cloud migration projects underway, which involve multiple cloud data centers in multi-cloud environments. And all of this is stitched together with an identity, which is very often hybrid. And that means that the identity is spanned across both the Microsoft Entra ID and also the on-premise network, Microsoft Active Directory as well. So the risk here is that a threat actor gets access to one of these domains and then uses that to pivot to another domain as well. We call this a multi-domain attack, or otherwise known as a modern attack. And this is a big risk for many organizations. And this is the reason why customers invest in the Vectra platform. So moving forward from there, coupled with that, there are some common security challenges that we hear from our customer base and the wider industry out there as well. And that is to do with network coverage, observability, and threat detection. Network coverage, meaning that coverage both on-premise and in cloud environments. See those aggressive cloud migration projects, which I talked about earlier, often result in cloud environments in which the security team have very little to no observability and therefore control over as well. Okay, so what a modern NDR platform like Vectra provides is the coverage and that observability, which is absolutely key for threat detection. Now, let me just walk you through a quick attack anatomy here to outline, to dive a little bit deeper into this and just outline what a modern attack would look like on a modern network. So first of all, this starts with a host compromise, and this leads to a complete compromise of not only the network, but multiple parts of the cloud environment as well. And this could be something as basic as token thefts. And there are controls in place to stop this, such as EDR and conditional access. But these can, and what we've been able to prove out, these can be bypassed. So if a host is compromised, then this could happen in a number of ways. The threat actor could steal tokens and therefore compromise the account as well. And from there, the attack could follow multiple paths, and the sequence would be a common kill chain across the network. So if there's the reconnaissance, lateral movement, collection, and finally exfiltration, but also in the cloud environment as well. The threat actors using the stolen authentication tokens, authenticating as a user to the cloud environment, following a standard kill chain, and that could involve escalation, evasion of cloud native detection tools, as well as further credential access, which could lead to compromise of not only the IaaS environment, which is the virtual machines, but also the PaaS environment as well. So we firmly believe that the only way to effectively reduce the risk of this is via multi-domain threat detection, right? Signals from multiple domains, and that gives us not only coverage of both the control plane, but the network as well. So the control plane being the cloud backend and the portal, which anyone can use to manipulate resources and or create users. This is a fantastic source of signal, as well as, of course, the network as well. And the network being on premise in the cloud, and that gives us visibility and threat detection coverage of known attack techniques within the kill chain and known behaviors such as lateral movement, exfiltration, so on and so forth. Now, let me introduce you the Vectra approach to NDR in the cloud, otherwise known as a modern NDR. And that is we're leveraging multi-domain signals to provide the best threat detection, coverage, and capability for our customers. Now, when it comes to the network in particular, let's dive into that. The network is made up of two key components, especially in cloud environments. So first of all, we've got packets and we've got flows. Now, packet capture provides the most granular level of threat detection because the packet payload very often contains very useful bits of information or features which the Vectra NDR can extract to detect attacker behaviors. So this is a very, very key element of the Vectra threat detection platform, that is packet ingestion. Now, the next piece, and actually where this becomes problematic, certainly in cloud environments, is that packet capture can be very expensive or is not available at all. Certainly in some environments such as Azure in certain regions, there is no possibility of packet capture. So this means that there might be an agent-based approach, which is what some of our competitors like Darktrace or ExtraHop are doing. We don't believe in this approach because we think that agents are not the panacea, and they also provide additional complexities, and are not, again, not always available. So Vectra is going down the path, and the path that we've chosen, and we believe is the best approach to this, solving this problem, is flow log capture. This gives us coverage of multiple clouds, so that's AWS, Azure, Oracle, so on and so forth, but also the deployment is frictionless and automated. So flow log capture is very much significantly easier and more cost effective than packet capture, and it still gives us a very, very significant amount of observability and also threat detection capabilities, which I'll take you through now. So these are the key pillars that flow log capture can give. Flow log capture plus packet capture can give us. Okay, the two combined, both observability, as I said, signal for threat detection, and then control. So observability, we want to understand exactly what's going on in our environment. We want to understand where our key assets are, and we also want to understand what the traffic boundaries and traffic flows are. So this is what the Vectra NDR platform can provide, as well as signal. So it's very important to detect anomalous activity, but we must be very careful to counterbalance that with alert noise. This is a very, very big problem. So Vectra is striking that balance between signal and alert spam, quality signal and alert spam. And this lets us detect key activities or behaviors such as lateral movement. And in the control pillar here, Vectra provides zero trust segmentation. And what this means is observability is key to this, because it gives us a view of traffic flows within our environment, both authorized and non-authorized, and then allows us to validate where our segments and traffic should or should not be flowing. So let me just share with you some quick key use cases. So just to dive in on that lateral movement, because that is something that we've been hearing from many customers who have undergone aggressive cloud migration programs or cloud migration projects. They don't understand the lateral movement, and there's various different levels of lateral movement within a cloud environment, all the way down from the host level, the subnet level, the VPC level, the intra VPC level, and also the region level as well. Okay, so and then on top of that, you've got within boundaries, you've got trust boundaries such as production and non-production, and where the traffic should be flowing between the two of them. So observability is absolutely key to enforcing this, because the smaller and the more segmented and the better understanding we have of our cloud network, the more we're able to contain the blast radius of an attack and actually significantly reduce the risk of that cyber attack that I just walked through previously. So what Vectra Fusion can give you via flow log capture is an understanding through observability, understanding of east-west lateral movement. And this then lets us validate the not only the traffic sovereignty, but the zero trust segmentation. Okay, so this is important as well, because we need to understand where our traffic is flowing from and to, and that includes, as I said, not only VPC but region and cross account as well. And this lets us identify unexpected egress paths within our environment. We can validate whether they are authorized or non-authorized, and then we can build detections in there as well in order to help us continually validate that. And on the point of continuous validation, right, or just to add to the threat detection use cases, not only observability, but Vectra Fusion via flow log capture can give us threat detection capabilities and use cases across the kill chain, across the standard kill chain. And this means that we can detect effective attacker behavior within the IaaS environment, and that follows the standard lateral movement, reconnaissance, data exfiltration, so on and so forth. Now, back to the continuous validation. This comes down to the deployment. So it's not only the initial deployment, but Vectra Fusion gives us the capability of continuous deployment as well. Cloud environment is very, very fluid, and one of the big challenges that many of our customers have is that workloads and teams and instances and VPCs and so on and so forth are being spun up and spun down again, conversely, at a very, very fast rate. So it's very, very important that the cloud environment as a whole is monitored continuously, and via things like Terraform and automations, Vectra Fusion can actually automatically onboard flow logs from VPCs that are newly created within the environment. So not only does this help, as I said, with the initial deployment, but with the ongoing validation as well. Coupled with that, with the observability and threat detection and segmentation use cases, you can effectively significantly reduce the risk of a catastrophic cyber attack to your cloud environment. Now let's move on to the demo. So what we're looking at here is the Vectra Respond dashboard. Now we know that Vectra is a threat detection platform that covers the network and cloud environments as well as identity. And what we're specifically looking at is a prioritized entity, which is
in fact a host. And Vectra is telling us that this is prioritized because based on the behaviors that Vectra has observed in the network traffic, this host is showing a high degree, or Vectra is telling us that with a high degree of confidence, this host is likely compromised based on the behaviors that it has observed here. Now, one of the things that we want to do when we're responding to this particular type of incident, once this has been qualified, is we want to understand the blast radius. So this tells us in the Vectra Respond console, we can actually pivot to stitch together the sequence of activities that made up this attack, one of these being lateral movement. So if I wanted to understand the blast radius of this particular intrusion, I could expand this here and I could see that actually my desktop, which has been identified as being compromised, has had lateral movement to these two hosts here. Now, this being an NDR platform, Vectra is detecting these behaviors with the use of packet ingestion, and I can see here that I've got lateral movement attempts to a DC2 host, which appears to be hosted in AWS, as well as an EUDB5 host, which is also hosted in AWS as well. Now, following the sequence of the attack in a similar way, I would wanting to be understanding what activities certainly took place against the subsequent host, and following that path of investigation, I do reach somewhat of a dead end. And the reason for that is because this particular host is hosted in my AWS environment. It is an EC2 instance, and because of the nature of my cloud environment, and for the reasons that we discussed earlier, we're not capturing packet for this particular host. Now, this can be a problem because we're not getting visibility from a packet level, but thankfully we are still monitoring our AWS environment with Vectra Fusion at a flow log level. Remember, we discussed the difference between packets and flows, and what I could do then to continue this investigation is look at the underlying flow data in Vectra Fusion, and I can very easily pivot to Vectra Fusion from the Vectra Respond console using the pivot point here. So if I go to investigate, what that will do is that will bring me into the Vectra Fusion console, and that is centered on this host. So there are numerous dashboards. If I just explain this to you, there are numerous dashboards included with the Vectra Fusion console, this one being a host investigation dashboard. And what we're specifically looking at is investigating the EUDB5 host, and this is a database server which is hosted in AWS, and this dashboard is intended to show me information that is relevant to investigating a host that we suspect might be compromised. So observability is very key in this scenario, because as I said, we want to understand what the blast radius might be. So things like destinations from our infected host, or potentially compromised host, to other machines, and destination ports, and then also traffic maps. These are all the things that Fusion gives us, as well as top destination ports. These are all the things that Fusion gives us to help us understand the flows of traffic surrounding host at the time of the compromise. Now, there's also detections included, and the first thing that we see here is that our EUDB5 server looks to have triggered a database to Dropbox exfiltration. And what this is effectively showing us that Vectra Fusion has detected a scenario where the EUDB5 host has been seen to communicate with Dropbox. And this, of course, is against policy, and this is not something that is authorized within the environment. However, in the context of the intrusion, knowing that this is potentially part of a network to cloud pivot, this is very interesting to us, and we want to know exactly when this happened and how it happened. So this is visible. If I go into this particular event details, what I'm looking at here is I can see that we've got traffic from my EUDB5 host, which is shown here, to an IP address which is known to be involved with Dropbox, and it happened at this time. So let's go back here. Additionally, there is detections to database to ITAR countries, which otherwise known as countries which are known to be involved with international arms trafficking. So again, what I'm interested in is what took place, when it took place, what took place, and when it took place. So what took place here is that there was a traffic flow from our EUDB5 server to a country which is being identified as a country code that is designated as an ITAR country. It took place at this particular time. So that's interesting to my investigation. And then to follow on from that, I would actually use this particular graph here to understand more about the communication flows from this particular machine, certainly if it is involved in a compromise. Okay, so that's a quick overview of how you'll conduct an investigation. But what about some other pieces of Fusion? Well, let's look at the multi-cloud visibility. So, and this is very important because many organizations don't have a single cloud. they've got multiple clouds. Usually those clouds could be, the cloud environments could be AWS, it could be Azure, it could be Oracle, so on and so forth. It's important to note the Vectra Fusion can capture flow logs from all of these environments and normalize it in a single console. So almost at a glance, and this could be very useful for more performance monitoring. I wanted to see how much traffic is actually traversing through my AWS environment, through my Azure environment, and then lastly through my GCP environment. As you can see, we've got 12.09 petabits of data actually traversing through my GCP environment, which is quite substantial. But having this visibility means that I can effectively monitor the performance of my of my various cloud environments, and this is key to observability. So let's dive into maybe one particular area. So what we're looking at here is the details of a particular VPC that's hosted in AWS. Now, when it's important to note that when Vectra Fusion is first deployed, there is automation capabilities, which means that VPCs can be automatically onboarded, but also VPCs can be automatically onboarded on an ongoing basis as well through the automation. We've got customers that were onboarded into Fusion, thousands of VPCs were onboarded into Fusion using the automation, and it also means that the automation will automatically add VPCs as and when they're provisioned by development teams. So this means that the security team has always got visibility of the traffic and the assets within AWS. So here is an example of what we might be looking at when a VPC is onboarded. So it's important to understand the visibility or establish the observability of flows within your VPCs. East-west lateral movement could mean VPC to VPC traffic, and understanding what that traffic effectively is within your environment, and then mapping that to authorized traffic flows and trust boundaries is important, because that's where we can start to define the segmentation policy within the cloud environment, and that allows us to derive detections specific to your environments for certain instances where there is east-west lateral movement that is unauthorized, because that is something you want to know about. So things like top talkers, protocol distributions are all very important, but the traffic flow diagrams, the traffic flow charts are where you can get a lot of value from. So in this particular scenario, we've got traffic that comes from our prod VPC, and that looks to be destined for a dev VPC. So that is according to the label of the VPC within AWS, and that's normalized within the Vectra Fusion console. And this means that we can see that here within this particular dashboard. We can also see traffic from AWS Jumpbox to our dev environment as well as traffic from IP address into other parts of my VPC. Or other instances hosted within my VPC. But this one is where I'm most interested in. Typically speaking, you wouldn't want to be having your prod traffic flow into your development traffic, and this is the level of observability that Vectra Fusion can bring you. But as I said, it's important to establish that this is unauthorized, because what we can easily do is we can create what we call a detection model, so that once that traffic has been observed, then this is going to trigger an alert for the SOC to investigate, because this would mean that there is an unauthorized trust boundary violation. And this is something that Vectra Fusion can do using the custom detection models. So we've got a detection model here, zero trust boundary violation within AWS from prod to dev, and it is as simple as defining an NQL expression, and this looks like it effectively looks like this. So we've got flow traffic where we've got the label is dev, and any flow traffic where the label is also prod as well. So that's to or from the prod or dev environments, any kind of flow data within my AWS environment, create an alert for that, and then that can be something that is actionable and reactive for the SOC to deal with. The SOC is not necessarily going to be looking at these types of dashboards on a daily basis. Dashboards within Fusion are very, very flexible, and we can create SOC-ready dashboards, but it's important to establish the observability of the environment using Vectra Fusion, and then using Vectra Fusion, understanding what those traffic flows are, mapping those to your authorized traffic flows according to your segmentation policy, and then defining custom detection models to alert the SOC when one of those trust policies or trust boundaries is violated. The last piece that is important to note here within Vectra Fusion is that Vectra Fusion, not only can you define your own custom detection models, which we would help with during deployment phase, but out of the box, Vectra Fusion comes with over 300 detection models, which are related to flow data and related to known attacker behaviors according to the MITRE kill chain, things like DNS reflection, DNS tunneling, and so on and so forth. Hopefully that's been useful. Thank you very much for your time.